What's up, Wahi? We're gonna be watching solving the hardest problem in physics. Lock in.
Imagine you leave Earth in a spaceship traveling in a straight line and you continue on this journey forever. Will you ever reach the edge of the universe? Is that even possible? This is perhaps the hardest and most mind-blowing problem in all of astrophysics, and there are really three possible solutions. Either you eventually do some kind of loop and arrive back here at Earth. Alternatively, you could continue forever and ever through infinite space, never looping back to Earth. The last and most mind-blowing solution is that maybe you'll eventually come across the edge of the universe, a barrier where all of space and time ceases to exist. And if you did make it there, what would you see?
I think about that sometimes. Like, if we did make it to the end of the observable universe, like, what's beyond the observable universe? Like, because there has to be something for it to expand. But, like, what's there? Is it just darkness? Is it just nothing? Not blackness, not anything, just nothing. Who knows?
Problem has stumped scientists for thousands of years, and today we are going to try and solve it together. Let me ask you a question that you might have never even asked yourself because the answer seems so simple. Why is the sky dark at night? The obvious answer is, well, the sun isn't illuminating the surface of Earth where you are, so you get to see the true darkness of space, sprinkled with twinkling stars, planets, and galaxies. But I mean, on a deeper level, why is space actually dark? Think of it like this. It's certainly true that not all of the night sky is dark, right? We can see these bright stars, very similar to our sun, faintly shining all around the sky, and space is full of these stars. But what if the universe were infinite and eternal? If this were the case, you should be able to look in any direction and eventually you should find a star or a galaxy. This would make our night sky as bright as the sun. No darkness. But this is not what we see. Maybe this
That actually just like flashbanged me.
means the universe is not infinite. Maybe there really is some distance away from us where the stars and galaxies just simply stop. The edge of the universe. Well, not quite. This argument is known as Olbers' paradox, named after the German astronomer Heinrich Wilhelm Olbers. So what's the solution?
I'm gonna be right back. I'm back, but let's continue.
Why doesn't the night sky look blindingly bright? Well, to answer this, we need to go back to the beginning. The best way we can approach this problem is to first try and figure out whether the universe is infinite or finite. 13.8 billion years ago, the universe as you and I know it today began with the hot Big Bang. At this time, the universe was completely filled with
I'm back, but making sure I'm still recording.
matter, antimatter, and radiation. It was extremely hot, dense, and rapidly expanding. This expansion has continued for billions of years, space itself growing faster and faster until we get to today. When astronomers look out to distant galaxies, they notice something strange. The further away a galaxy is, the faster it appears to be moving away from Earth. So what if we take this to the extreme? What if we look so far out into the universe that the galaxies are moving away from us faster than the speed of light? At this distance, the light emitted by the galaxy is moving too slowly to reach Earth. Light emitted today by anything beyond this mysterious barrier will never reach us. Nothing can move through space faster than light. We know this, but that doesn't stop space from expanding and behaving however it wants. Because the expansion of the
And it died.
universe is uniform, this happens at
All
the
the
same
fiends know
distance
what I'm talking
everywhere
about.
around us. This is known as the Hubble
It
sphere,
died, so I'm gonna go
and it's
plug it in
currently 14.4
and be right back.
billion every direction. And here's the amazing part. Because of complex reasons relating to dark energy and the rate of expansion of the universe, the Hubble sphere is still expanding every single day and has been growing like this for billions of years. This means that if some galaxies outside the Hubble sphere have emitted light traveling towards us in the past, eventually the size of the Hubble sphere will grow big enough to include this light, at which point it begins its journey towards the Earth, and after billions of years, we will finally get to see it. If you think about it, that's kind of amazing. We can see galaxies moving away from us faster than the speed of light. This creates a sphere of space bigger than the Hubble sphere that we can still observe.
Sorry for keep cutting. I just, have to do certain things. But
This is known as the observable universe, the true cosmic limit for everything we can possibly ever learn about. It is 93 billion light years wide. The reason it can be this big, despite our universe being just 13.8 billion years old, is because, well, the universe is expanding. This sphere contains everything we can possibly observe. No matter how hard we try or how amazing of telescope we build, we will never, ever see beyond this boundary. But that doesn't mean that this is where space ends. Quite the opposite. There is certainly much more universe outside of this boundary. The fact that the universe is expanding is actually the key we can use to solve Olber's paradox from earlier. Look at this image. This is the famous Hubble Deep Field taken by the Hubble Space Telescope using an infrared camera. Okay, so just quickly jumping in here, and I'm currently in the Swiss Alps filming a few videos that you'll eventually get to see. Showed you is one of the most important and interesting images in the history of astronomy. Taken over the course of just 10 days, they captured over 3,000 individual galaxies in just a tiny patch of sky. But there is just too much interesting science to be covered in this video, and we don't have time, and that's why I've partnered with Magellan TV. They have an awesome documentary, but I hope you do, that I'm sure it's even better in the description. Extends distant galaxies move away from us here on Earth. As they do this, the light they emit gets stretched out, where it is then shifted towards the red end of the light spectrum.
again, I'm not gonna really be commentating. It's just I really don't know what to commentate about this video. It's just a reaction.
The farther away they are, the faster they move away.
It's not like you're gonna make it this far into the video anyway. But if you do, comment Pizza Hut
from us, so the more red-shifted their light becomes. This keeps going all the way until the light they emit becomes so red-shifted it becomes infrared. At this point, we can't see them anymore because our human eyes just can't see in the infrared. That's why the night sky appears dark to us. To go beyond the observable universe into the unknown and figure out which of the three possible solutions to what's at the edge of the universe is correct, we first need to understand the shape of the universe at large scales. It's easy to suppose that the universe would just assume the shape of a sphere. I mean, if the Big Bang started in some point and expanded outward from there, then surely it would just expand into a big ball containing all the matter of the universe. This makes intuitive sense, which is why many of the great philosophers like Aristotle, Ptolemy, and Plato all believed this to be the case. But
I don't know if you noticed that pattern there. They all had like the same beard.
Matter of the universe. This makes intuitive sense, which is why many of the great philosophers like Aristotle,
Look at his beard.
Ptolemy, and
Look at his beard.
Plato all believed.
Look at his beard. They all kind of like match in their own way.
Believed this to be the case. But our observations of the universe don't seem to agree with this, and like many things in physics, we have Einstein to thank for it. General relativity tells us that space itself is not just some flat grid, but rather a curved fabric of space-time, where mass and energy necessarily warps the fabric itself. You've probably seen demonstrations like this, showing how this fact creates the gravity we observe in planetary motion. But this same truth applies to the overall shape of the universe at large scales as well. There are three options. Space-time can be positively curved, in which case the universe would be shaped something like a sphere, but in higher dimensions. It is not possible for your 3D brain to visualize these higher dimensions, so for ease, we will just consider it to be a regular sphere like here on Earth. In this positively curved space, light traveling in straight parallel lines will eventually converge. Another option is space-time can be negatively curved, something like a saddle. In this case, those same parallel lines of light would diverge, moving away from each other. Or finally, it can be completely flat, where it is not negatively or positively curved at the largest scales. In this case, the parallel lines of light will stay parallel for eternity. It's really easy to see how in the first positively curved solution, the universe could be seen as both infinite and closed. It would essentially be like the entire universe existing on the outside of a sphere, very similar to how we exist here on Earth. You could fly your spaceship around the outside of this sphere universe, eventually arriving back where you started. But it's not quite as easy to imagine how this geometry would work for the other two solutions. Maybe the universe would just extend out infinitely forever, never repeating back on itself. Or maybe the universe really does form this strange saddle shape. Well, which is it? Cosmologists have measured the curvature of space-time in our universe using triangles and the cosmic microwave background. In positively curved space, the three angles in a triangle would add up to be greater than 180 degrees. For negatively curved space, these angles will add to be less than 180 degrees. And of course, in a flat universe, they would add to be exactly 180 degrees. By looking at the cosmic microwave background,
There's no way the universe is literally just flat.
which is essentially a snapshot of the light left after the Big Bang, they can measure these angles for our universe. Okay, you've made it through the hard stuff. Now you understand that space-time appears to be flat at the largest scales. But what can this tell us about the true shape of the universe? Well, if our flat universe is finite, it could be that our observable universe is just a tiny section on a more massive curved surface. This could be something like a hypersphere universe. It is really quite similar to how here on Earth, our experience feels like the Earth is flat, because we are just so small compared to the size of the Earth. Maybe the observable universe only occupies a tiny section of the broader universe such that it appears to be flat. This version of a finite universe would have to be at least 1,000 times larger than our observable universe. But what if the universe is just truly infinite? This is what most cosmologists believe today, and it has some scary implications.
Tired of guessing what's wrong with your YouTube videos? Well, vidIQ has the answers. Just connect your YouTube channel.
In this
I will be back. This is going to be the last cut. It's not like you're going to be here anyway, but
truly infinite
And we're
universe, if it stopped expanding, you could fly your spaceship in one direction forever and ever, without ever reaching an edge or looping back around to find the Earth. And here's where the scary problems come from. If the universe is truly infinite, then everything in theory could repeat. Infinite Earths identical to ours with slight variations. Maybe out there in the universe, there really is a version of you watching.
if the universe is infinite, there's definitely a planet that's exactly like Earth. If it's infinite, at least one.
This YouTube video, but that version decides to not subscribe, while this version of you of course subscribes right now. I know this seems
Even though you're not here, go and subscribe.
like just complete science fiction, and it probably doesn't sit right with you, but this cosmological model of an infinite universe predicts this as reality. This exact copy of you and every other variation that you can think of should live in a galaxy 10 to the power of 10 to the power of 29 meters away from us right now. That is 10 followed by 100 billion trillion zeros. It is effectively infinity, but if the universe is truly infinite, you could theoretically reach it, assuming the universe stopped expanding right now. And if you think about it, like really, really think about it, it kind of makes sense. I mean, everything here on Earth is made of a finite amount of particles arranged in a finite number of ways. So if we have infinite space that is completely filled with galaxies just like ours in all directions, statistics says there will be repeats. These repeats could genuinely be anything. Maybe out there in the universe, there's a version where you are teaching me this topic, but through your own YouTube video. Who knows? Even if there are infinite versions of you out there somewhere in the universe, we will never reach them, and not because our spaceships just won't be fast enough, but more specifically because the laws of physics have locked us into this tiny section of the larger universe. Do you remember the Hubble sphere that we were talking about earlier? Everything beyond this border is traveling away from us faster than the speed of light, meaning if we could make a spaceship that traveled really close to the speed of light, we would still never catch up to them. 94% of all the galaxies we can see are beyond this boundary today, meaning no matter how hard we try, if there are aliens living in those galaxies, we will never get to meet them. And
We're either alone in the universe or we're not. Both are equally terrifying.
the number of places we can visit in our universe is just going to keep going down. Every single second, 60,000 stars pass beyond this horizon, becoming unreachable by humanity. That is more than 50 million stars since the start of this YouTube video. 100 billion years from now, every single galaxy will be too far away from us to ever reach. In 2 trillion years,
Besides Andromeda.
all of the galaxies will be so far away that we can no longer see them.
Because in a couple billion years, Andromeda's going to crash right into us.
At all. The universe as we know it, all the beautiful galaxies, nebulae, clusters, all of it will slowly fade out of view beyond the event horizon, as if it were entering a black hole. No matter how amazing a telescope we manage to build, we will point it in every direction and always find the same thing: silence and darkness for the rest of eternity. This means that if humans evolved on a planet like Earth 2 trillion years from now, they would have never, ever discovered galaxies. To them, the universe would be just their home galaxy. They would have no knowledge of the Big Bang, galaxy formation. They'd never learn about the cosmic microwave background and would probably believe that the universe is just static and eternal. And they would have no way to discover anything we know today. While this future sounds depressing, it's not really. I mean, the galaxy does have more than enough space for humanity to thrive within. We still have no clue how to leave our own solar system and visit other stars a measly 4 light years away, let alone billions of light years. Regardless of all of that, if you've made it this far, you now understand the true scale, size, and shape of the universe better than any astronomer or cosmologist did just 100 years ago. You should be proud of yourself. You can now go tell all of
That's kind of crazy.
your friends that we live in an infinite, flat universe with no edge. Probably. But don't get too comfortable. Humanity will continue to explore and discover the secrets of the cosmos for billions of years. And who knows? I'm sure that by then, or even just 50 years from now, cosmologists will look back at this video in awe of just how little we really did know about the shape and size of the universe we call home.
Damn. This is gonna be the next video, Last Train, but that other video, it was pretty good, but could have been better, could have been shorter, but that's it for this video, and